nice hot coffee on a nice cold snow day morning. Okay, we've been looking at structs in Racket and the methodology, the design recipe, and how it applies to structs, and pretty, hopefully, straightforward. Reminiscent of making objects in Java. Let's go ahead and do that exact same example we did about books. Let's do it and see what the corresponding Java looks like so we can point out the comparisons. And we're going to use Java records that might be a little bit new to you. So first I'm going to go back and remind ourselves of what we had in Racket. We had a defined struct book. We listed our 4 fields and their types, and then we went ahead and made examples of the data and so on. So let's go ahead and look at that same thing in Java. Here is the one line that is defined struct/contract. We say record book instead of class. This does make a class, but we'll say record book. And instead of putting the fields inside the curly brackets like we usually do in Java for a Java class, well, by calling it a record, it's almost a class, but we list the fields up here. I'll say why in a moment. So yeah, record book, and it has 4 fields: string title, string author, int num pages, boolean is copyrighted. Okay, and now you're thinking, well, what's the difference between a class and a book besides putting the fields in a wacky place? We'll see in a second. A record gives you a toString, the one you really want, not the crappy one that gets built into a regular Java class. And it gives you a not just toString, but also a constructor. A good constructor, not the crappy one that does nothing and leaves all your fields zeroed, like the default one. And it also gives you equals that you want if you have immutable data, and it actually ends up being immutable. That's what record is. Those are the differences between records and class. I'll come back to that. Don't sweat it. But the point is, this here is valid code. It compiles. Let's go ahead and try compiling it. I'm going to try compiling and running it. And let's see down here, Java C succeeded. The Java main method not found. Well, I didn't have a main, so that's reasonable enough. Okay, cool. So this lets us go ahead and defines the struct just like we had in Racket with defined struct. Say we want to go ahead and make some examples of the data. Next thing we did in Racket, well, let's go ahead and do that right here. Code in Java needs to go inside a class and pretty much inside a method inside that class. So, okay, we'll go ahead and do that. I'm going to go ahead and I have something done here. So I'm going to make a little method inside the curly braces of the class of the record. We're going to go ahead and have a little method called test basics. It's going to make a book here. So this is the line to draw your attention to. Yeah, just like make book in Racket, and you've seen this before, new book. But notice that I didn't write any constructor myself. It made a constructor, and you know the signature of the constructor? Kind of looks like that. That's why in a record they put the fields up there, because it's going to remind you of what the signature for the constructor. And this is the one real basic constructor that is required, the one that has all 4 fields and initializes all 4 of them. So let's go ahead and just make sure this runs, compiles and runs. It's going to compile and give the same error, no main method found. Okay, let's go ahead and put in a main that just calls that test basics. Public static void main string ... I'm going to name it __ because I'm not going to use that variable. I don't want to draw a programmer's attention to the variable name that I don't use. __ looks so minimal. It tells the reader, tells the programmer, hey, this is an argument that kind of has to be there for whatever reason. Ain't going to get used. So good. Okay, and let's go ahead and call test basics. So I'm going to have main call test basics. Test basics is going to make a book object. I'm going to make another book object here as well. And we're also going to print it out, which is going to call a toString. In fact, here's the toString call explicitly. And now let's go ahead and compile and run. And it just says, ooh, I'm going to move my talking head here. I just read, and now here's a toString that we didn't write. is provided for you by the fact that we're a record. So the record provided a constructor for us that was good. It took the 4 fields and just stuffed that really super boring constructor that's so boring that IDEs often have a little option built in saying create constructor from public fields or something like that. And it was the most boring code ever tried. It was so boring that other programmers wrote code that made that program for you, made that constructor method for you. Yeah. With record, it's built in the constructor, and toString, a reasonable toString. So it looks as book, B-O-O-K. Let's zoom. No, go here and zoom in a bit. There we are. It prints as the name of the record, square bracket, and then the 4 fields. Title equal the soul of wit. Author equal anonymous. I wish these were put in quotes so I could copy paste it back in somehow. In fact, I wish there was a real Java code. I wish it said new book, open paren, title in quotes, just like I had up here. I wish it printed like that. That's what Racket does, right? The way it prints out happens to be, by luck, the constructor, a valid Racket code for calling the constructor. This isn't valid Java code the way it prints out, but it's pretty close. Lets you know, it is good for looking at and seeing what your object looks like. So that's our default constructor, our default toString, and we get those for free with records. Okay. I will point out that, so first of all, you may have wondered, or maybe not, but sure, Java privileges strings. If I didn't go ahead and include the .toString, it would still see, oh, I have a book object, I want a string object. I will go ahead and call the toString for you. Java privileges that one method over all other methods. It calls it for you. So we don't need to call it. In Racket, you would need to call it yourself if you wanted to call its toString. Now the REPL calls the toString, the read-eval print loop already. Okay, cool. I will point out that the following, this goes ahead and makes a book, assigns it to a variable that is meant to hold the book. Here I just made it call the toString and then threw it away. That's fine. I will point out that this won't compile. I'm going to go ahead and take that book I made and put it in the variable cat, or CIH for cat and hat, and assign to a field, and that's not going to work. Let's see what the error message is. Cannot assign a value to a final variable num pages. Okay. In record, all fields are final. This is an immutable class that gets created. And that's part and parcel of using a record rather than a class. You don't get any setters. Okay, cool. We've now done what we did in Racket. We defined our class. We went ahead and made some examples of it. And then we went ahead and said, hey, let's write the template. Okay, I mean, we'll go ahead and write Embiggen in a second, the same way we wrote it back in Racket. But what does the template look like again for a struct? If you have a struct with 4 fields, any function. So when I say again the template, any function that handles a book, what is it going to look like? Oh, it's going to go and have to pull out those 4 fields. Okay, that's all I can tell you. But it will kind of have to do that. Whatever you're doing with a book probably depends on one to all of its fields. So, okay, cool. I'm going to go ahead and just write, I guess, in a comment here, or template for any function dealing with a book. Okay, and let me scroll down a bit. Gosh, what do I want to do? I want to say the return type can be any. How do I say any in Java? I guess I could write object. Yeah, not quite, but okay, close enough, I guess. Hey, I'm going to have some method. If I'm feeling OO and want to make this a straight up method, I'm going to say, okay, it goes ahead and call it func for book, just like before. And what is the argument we pass in? Well, it gets passed in a book object, the book that we're going to call something on, which we don't actually write. It looks just like this, right? But we don't actually write that ever in Java. Our methods do get one parameter passed in that we never mentioned, and we don't get to name that parameter. It's already named THIS for us. And that's all, by the way, that's all the keyword this means, unless you're a constructor calling a constructor. But, yeah, so it's just the name for that argument that got implicitly passed in. Okay. And what does the template look like? Gosh, I'm going to have this dot my 4 fields. I need to extract the 4 fields. If I have struct with k fields, call the k getters. What's the built-in getter called? The built-in getter for author, just called this.author, and there's no parentheses involved in that, even though we've seen now in Racket, this sort of changed how I viewed getters. The primitive built-in getter. I viewed this as, no, this is some sort of memory access. Hogwash, there's nothing about memory in Java, okay? Java says this.author is a function, it's the function that takes in the object before the dot, that's it's passed in, and dot author is the name of the method that extracts that field. And you pass it this. We don't pass it with parentheses because it's just a function, but we have a whole different syntax for calling it. Okay, but yeah, you have a string, this dot author, you have this dot title. I guess I should do it in the same order I declared them in. What else do I have? This dot num pages, and this dot is copyrighted. Oh, I can't put a question mark at the end of my Java name. And I'm like, yeah, somehow this is going to have to get, these things are going to get put together. I'm going to use these four pieces of information. I'm going to combine them somehow. And so I guess I'm going to call, I want to be exactly equivalent to the Racket. Oops. I would go ahead and write it like this. I'm going to call some function, I'll probably return that. So this I guess would be the exact analog to the Racket template. Hey, have 4 things, do some work with them. So I'm imagining that as a function call to an unknown function ... But in general, I mean, this is, we'll do whatever work we need to. So maybe I should take that out, but. What's going on there? Okay. Yeah, this I think is the, I would consider this the template in that somehow combine these 4 pieces of information. Okay, so let's go ahead and write the function embiggen, the same one we had from last time. Now that we have our template that and again, I can write 20 functions involving books, 20 methods. I can copy paste this and now go ahead and use it. And you might say, Barland, you're weird. Why are you saying this dot author? You can leave that off in Java. Don't you know anything? Yeah, I'm not smart enough to do that. I like a very simple rule. You say object and then a dot and then the field name. And that is how you get a field out of an object. And I know you can leave off which object you're using sometimes. In some contexts, if it's not static and you don't have another local variable whose name happens to shadow the field, as long as those hold, you could leave it off. I don't remember all those rules. I've been burned by those rules before. I do have a local variable whose name is the same as the field, and suddenly things are really bizarre. So yeah, very simple rule. That's how you access a field in Java. So I'm going to spell out this dot. You don't need to. That's fine. Okay, so looking at the template, let's go ahead and look for books. So let's go ahead and write this function. Embiggen takes in a book object, returns a new book that has 3 times as many pages because it's in large print for old guys. Yeah, so what do we do first? By the way, this is step 1 of the design recipe, define our data type. Step 2, make examples of the data. Okay. Step 3, give me the template. Step 3b, a template for something with 4 fields, a struct. Okay, and now we're going to begin writing a function, embiggen. So what's the first part? Yep, we write our unit tests. So I'm going to go and actually have this already typed in down here. So oh, I don't have it down here. Let me go ahead and go to this other window and copy and paste. we're going to go ahead and write some unit tests. And I'll put it right here. Static void test and begin. Okay. Again, I'm not going to go ahead and give the purpose statement for this. In Racket, we just put these tests at the top level. Here I have to put them inside something. If you have a method called test and then the name of some other method, people know what you're doing. You're testing that other method. So we're going to write and begin. So we write test and begin. I'm not going to put down a purpose statement for it. And here's a new example. If I take this book here, The Cat in the Hat, and then CIH, and I call CHAmbiggen, assert that CIH.ambiggen returns is dot equals to new book, The Cat in the Hat, blah, 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 but with the 74 here. Okay, so that is our first test case. And then when I had another test case, I made a book that was 0 pages long and not copyrighted. I embiggen it, and I assert that dot equals gives me back that thing here with 3 times as many 0 pages. Okay, so now we can go ahead and see if this runs. I can't quite run it yet. Why not? I need to go ahead and have a signature for embiggen, and I'll want I guess a purpose statement as long as I'm doing that. So I go to my already working copy that I've done in advance. Here's my purpose statement. Put it in JavaDoc format, but that's fine. Again, your purpose statement should go ahead and mention your parameters by name and be short and sweet and talk about what it returns, not how it returns it. Okay? I'll return a book like this, but with bigger font, more pages. Okay. So the fact that it's 3 times as many pages, maybe that's something I don't want to nail down in this spec here. Maybe in my implementation happens to use 3 times as many, but I'll leave it a little bit open in that spec. Okay. Though certainly my test cases nailed down that idea. And in Java, you can go ahead and you don't need to, I used CodeFont to recognize, say, hey, I'm actually talking about my parameter name. It's traditional in Java to use the word this in English without saying it's code, but we all understand you're actually talking about this object when you mention that in a comment. Okay. So we'll go ahead and have embiggen. It's going to return a new book. Remember, that's the one thing that's unusual about this immutable program. We're not going to take the same book and mutate it. We're going to actually return a brand new book. And so what can I put in to return? I need to put something here, an actual book object. Could I put null? Yeah, but now I'm just cheating Java's type system. Why? Because what is the type book in Java? It's not actually the type book. If you say book anywhere in Java, it's actually talking about a union type, book or null. So I want to be using real books here. I want to avoid null altogether. It's a 4-letter word. So I'm going to go ahead and copy and paste this. Copy. I can paste. There we are. And just return that one here. That's my stub. This will now compile. I'm not going to pass my tests, but I can try doing it. Oh, I do have some errors. Book in line 16. Oh yeah, this here. Okay. I can't really do this, so I'm going to put this whole template in here, and I'd have to have a return statement. I'll just put the whole dang thing in one big comment here. So comment.our_template, we can't have templates as valid Java code. Oh, and I can't nest my comments like I had up there. Oh, Java, you're killing me. Okay. All that work just to comment out something. Okay, there we are. Got an error. I didn't put my closing bracket, the one that matches the record statement, way up at the top. Up on the top line there, that open bracket, and there's the corresponding close bracket. So it's still like a class. We put all our methods inside the class, even though it's a record. And now I can run and hopefully fail all my test cases. What is this? Implicitly declared classes are a preview feature. Public static void main. Why is do? I'm not trying to declare a class there. It thinks void is a class name. So, why do I have that? was sitting here. I put my close bracket in the wrong place. Okay, great. Good thing I dealt with all that before I wrote all the code in my next big involved method. I mean, in our case, it won't be a big involved method, but if it had been, I didn't even need to work. Did I do something weird inside the middle of my thing? I know I have the error message, but even without looking at the error message, I knew that it was going to be a pretty superficial error because I haven't done anything difficult or hard yet. Okay. Main cost test basics, and that's what I'm going to call test in begin. So go ahead and update my main as well. So that ran, but didn't fail the test cases, and I'm like, oh yeah, I actually need to call my test cases from somewhere, so I'll put that in main. So again, another little bug I have there. Why did test and begin not fail? Test and begin's full of a... Oh, yeah. Java. What does assert do in Java? Absolutely nothing unless you enable it explicitly. By default, assert does nothing. When you run your JVM, you need to call it with java-enable assertions, else nothing happens. Oh my, okay. And now I run and I fail my test cases. Good thing I worked all that other stuff before I wrote. This is what I'm saying. I did not mean to make any of these mistakes, by the way. These are all genuine things that I forgot about, even though I've been doing Java a long time and Java records. But I still slip up. And again, I catch these errors because I'm running my test stub before I've even tried to implement the method. And I get all these stupid errors out of the way. Okay, now I'm actually failing my assert. Java laying assertion error. So I'm like, yeah, that's what I was expecting. And again, you're probably going to use JUnit and not have to call a test method inside main. The JUnit does all that for you and is much better than assert. And so you wouldn't have to enable them. But that's teaching JUnit, and I'm not going to get into that particularly. Although it's simple enough if you... Hardest part about JUnit, right? Installing it, getting it to run at all. Okay, great. We now have this. Now we need to actually write embiggen. And I guess I'm going to grab my 4 lines of the template, because that's really what I wanted here. Okay, what is my answer going to be? It's going to be return a new book. And now my test cases are like, oh yeah, it has a book object. This test case here really sort of did me good. I'm like, if this was the input, sorry, if CIH was the input, so let me actually do this one here. If this were the input, then this would be the output. Oh, the output is going to be a new book. Okay, helps maybe remind me that I'm not changing fields. Again, it would be an error to change a field in a record. But okay, so return new book and the author and the 3 times the number of pages. That was the embiggen part. Okay, or 2 times. Sorry, 2 times. It looks like. Whatever I did when I did my test cases, that's when I decided what that factor was. Same copyright status, get rid of that stub, and now it can run, and no assertion errors. Woohoo! Now we do step 8 of the design recipe, right? Okay, so that is record in Java. If I have to condense everything I've said in this whole thing down to a few sentences, a record is just like a class, except you list the fields right here. And you get the constructor, just like we did in Racket. And you get the toString, just like we did in Racket. And we get an equals that compares all the fields, just like we did in Racket. And it happens to be immutable. Is that a strength or not? Some you might argue on that one. But you get just like you do in Racket. In fact, Record is finally getting what Lisp had in 1967. Woo! Java 19 was a great breakthrough in Java. Okay. Sounds good. Your homework will have you do problems that take in an object and return a whole nother object rather than setting a field. That's one of the things we'll be doing. So here's the example that does that. Take care.